Okay, we're on part 2 of section 3.2, and again the I can statement is I can solve one-step equations. And we're going to start with a warm-up that kind of builds on the skills that we worked with in the previous video. How do you undo multiplying by 5? Well, remember we talked about inverse operations, add, subtract, multiply, and divide, and how some of them undo each other. So how do we undo multiplying by 5? Well, we would divide by 5. That would undo, that would undo multiplying by 5. And how do you undo dividing by -2? So if we undo dividing, we're going to be multiplying, and this one might take a little bit of thought. So we undo dividing by -2. So if we times something by a negative, it would be the opposite sign of what it used to be, and then we need to kind of change it back to the opposite of the opposite. So we're going to multiply by -2. Some people might think, oh, well, you undo dividing by multiplying and you undo a -2 by a +2. We don't do that. Okay, we're undoing the operation, not the number itself. So kind of keep that in mind. And then I want to take a look at a problem that a lot of people struggle with. This is 0 divided by 22. Again, the fraction bar represents 0, and please use those horizontal fraction bars. 0 divided by 22. Now, most people remember that there is a problem dividing by 0. But they can't remember what it is. So the answer on this problem is actually 0. And what I like to do is I like to do an example with pizza and people. So pizzas are the top and people are the bottom. So let's say we have a room and there are 22 people in the room and there are 0 pizzas there. How many pizzas does each person get? Well, if there are 0 pizzas and 22 people, each person gets 0. They get 0 pizzas. So if we have 0 divided by 22, the answer on that is 0. But what if we flip this around? What if we had 22 people, or 22 pizzas, and 0 people? How much does each person get? Well, if there are no people, the question doesn't even make sense as far as how many pizzas each person gets. So this one has no answer, and sometimes we'll say that it is undefined. So you can take 0 and you can divide it by a number, but you can't take a number and divide it by 0. So 0 on the top is okay. The answer is 0. 0 on the bottom is not okay. That's undefined. And most of the problems we're going to run into are something like this, so just keep that in mind. Now, hopefully with the practice you did yesterday, you can answer these questions here and kind of fill in the blanks as we go through. The goal of solving an equation is to get the variable on one side all by itself. So we can read the answer off on the other side. That's the whole point. And the answer, or in other words, sometimes we'll use the word solution. The answer is the number that makes the equation true. It's got to make it a true equation in order to be a solution. Okay? And when we solve equations, we use inverse operations. Inverse operations. And inverse operations, they undo each other. It's kind of like they cancel each other out. They make it as if they never happened. So the inverse of adding is subtracting. Inverse of subtracting is adding. Inverse of multiplying is dividing, and the inverse of dividing is multiplying. Now, we're going to solve some basic equations using multiplication and division today. So let's go ahead and take a look at these. It says solve each equation using inverse operations, and again, make sure that you show all your work. And I've got a couple things that I'm going to point out as we go through and solve these important ideas that if you get these now, you're going to be much better off in the long run. So let's take a look at this one. This says 5 times x equals -35. So 5 times whatever that original number was equals -35. Now again, you may be able to think of what the number answer is, but again, that's not the point. We want to make sure that we're showing our work and kind of arriving there so we can do more difficult problems down the road. These are really important skills to practice showing. So this is timesing by 5 times x. So we need to undo multiplying by 5. We undo multiplying by 5 by dividing by 5. So make sure you're using that horizontal fraction bar. We really get away from using this once we get to 7th grade or so. So we're going to divide both sides by 5. Again, if you divide this side by 5, it's only fair to divide the other side by 5. Now 5 divided by 5, what's going to happen is these are going to cancel each other out, and we're going to end up with an x over here. So these undid each other, and then over on this side we've got a negative divided by a positive, and let's see, so we get 35 divided by 5, so negative 7. Okay, so the answer is negative 7. And again, take note, there's really an understood 1 in front of this. So these two, 5 divided by 5, cancels to be a 1. So when we're undoing addition and subtraction like we did in the previous video and on the previous assignment, when we're undoing those, they cancel to be 0. When we're undoing multiplication and division, they cancel to be a 1. And it's important to understand when we say things cancel, you need to understand how they cancel and what they cancel to be. So we undid this, multiplying by 5 by dividing by 5. 5 divided by 5 is 1. So we've got our 1x over there, which is what we want. So let's take a look at this one right here. Y divided by negative 2 is equal to 10. Now you'll notice that in the warm-up question I actually asked you about these. So how do we undo timesing by 5? We said we divide by 5. And how do we undo dividing by negative 2? Well, we invert the operation. We undo that operation. So we're going to undo dividing by multiplying, but the number stays the same. So we are going to multiply this side by negative 2, and we're going to multiply this side by negative 2. So negative 2 divided by negative 2, these cancel each other out. They cancel to be a 1, so we end up with a y right there. And again, if you wanted to lightly cross those off, you could. And then we have 10 times negative 2, so that's going to be a negative 20, and that's the answer. Now, again, take note of this. When undoing division, it's always a good idea to use parentheses to show the implied multiplication. So when we undo division, we have to undo division with multiplication. And most of the time we use implied multiplication. So it's a good idea to use parentheses to show that implied multiplication. And we could put parentheses around each one of these factors, but it's always a good idea to put them around the second one. You can put more if you want to, like we could put them around here and around here. That would be just fine. But if you're going to put one set of parentheses, it's got to go around the second one. That's going to make things much more clear in the long run. So make sure that you do that. Now, just to double check and make sure that we're clear on how this works, the reason these two are the answers to these particular equations is because when we plug them in, we make the equation true. So I'm going to go ahead and check this right now. This says 5 times x is negative 7. 5 times negative 7 is negative 35. So that one checks out. We've got that one. And if we were to plug this in and evaluate, wherever there's a y, we put a negative 20. So this would be negative 20 divided by negative 2. And a negative divided by a negative is a positive, and 20 divided by 2 is 10. So you'll notice that that checks out. Again, you can always substitute back in and see if it makes your answer makes the equation true, and then you'll know if you got it right. So let's go ahead and do a couple more and hopefully make this a little bit quicker. So this is 12 equals negative 2 times n. So we're going to undo timesing by negative 2 divided by dividing by negative 2. So we'll divide both sides by negative 2. Remember, we've got to do the same thing to both sides. Multiplying by 2 and dividing by 2, those cancel each other out. Negative 2 divided by negative 2 is a positive 1n. I could write that if I wanted to. We normally don't. And then I've got a positive 12 divided by negative 2, so that's going to be a negative 6. So the answer on that one's negative 6. Again, plug it back in if you'd like, but that will make the equation true. And again, you'll notice that it doesn't matter if I've got this on the left side or the right side. So I can say n equals negative 6 or negative 6 equals n, doesn't matter. A lot of times it's good to read from the variable, but it doesn't matter if it's on the left or the right. So on this one, we need to undo dividing by 6. So I'm going to times by 6, and notice that I'll put the second factor on each side in parentheses. So those are going to cancel to be a 1. So I'm going to have an m on this side, which is what we want. We want the variable all by itself. And then over on this side, I have 6 times negative 9, so that's negative 54. So the answer is negative 54 on that particular one. Now, if you wanted to, you could do what we call a pancake flip. So it's kind of like putting a pancake flipper underneath there and flipping it over. So that means the sides would flip over and it would look something like this. That would be totally fine, but it's unnecessary. I like either left or right, doesn't make any difference. Okay, a couple more problems and then we'll do some from the assignment. There are a couple interesting problems from in this particular section. This one right here is one of them. So if you look at this problem right here, it says negative x equals negative 29, and this is where you've got to think about coefficients. What is the number in front of that x? It's not a 1, it's actually a negative 1. So that's really, the x has been multiplied by a negative 1. So we would undo multiplying by a negative 1 by dividing by a negative 1. So we'll divide both sides by a negative 1. So we get an x on this side because a negative divided by a negative is a positive and 1 divided by 1 is 1. So those would cancel each other out here. And then this would end up being a positive 29. So that would be the answer. Let's take a look at this one. We need to get rid of that 28 first so I can get the variable by itself. So I'm going to subtract 28 here, subtract 28, and we end up with 11. And that equals negative y. And some people will stop and they'll say, well, I got the variable by itself. But remember, we want the y completely by itself. We don't want a negative in front of it. We want a positive in front of it. We want that to be a positive 1. So I'm going to divide both sides by negative 1. So I end up with negative 11 over here, and I end up with y right there. Now, instead of using multiplication or division to change the sign of this, you could think of what the word negative means. What it means is it means opposite. So if we had this problem right here, we could say the opposite of x equals 7. So I don't want negative x, I want positive x. I want its opposite. So we could simply say we don't want negative x, we want its opposite, which is positive x. So we don't want 7, we want its opposite, which is negative 7. So we don't want the opposite, or we don't want negative x, we want its opposite, which is positive x. So we don't want 7, we want its opposite, which is negative 7. And let's see if the same logic works on these problems right here. Again, this was negative x equals negative 29. We don't want negative x, we want its opposite, we want positive x. So we don't want negative 29, we want positive 29. There's the right answer right there. When we got to this point, we don't want negative y, we want its opposite, we want positive y. So we don't want positive 11, we want negative 11, and you'll notice we get the same answer there. No problem doing it the way I showed you first, but that is a good way to kind of take a little bit of a shortcut as long as you understand why. The negative means opposite. We don't want negative y, we want its opposite, positive y. Now we're going to look at problems number 1 and 18 on the assignment. Then we'll look at number 8. But I do want to point this one out to you. This is kind of an interesting problem. This does have a fraction on both sides. But if you think about it, we're trying to get the y by itself. So you might want to think about how we get rid of dividing by negative 10. I'm not actually going to do that problem. I just want to leave that as a challenge. So if you think some of this stuff is pretty easy and want to challenge yourself, I challenge you to do that problem right there. So let's take a look at 1, 18, and then we'll take a look at 8. So here's problem number 1. You'll notice we've got x divided by 8. That horizontal fraction bar means division. So I'm going to multiply both sides by 8. Putting parentheses around that second factor there. These are going to cancel to be a 1, so I get 1x just like we want, and negative 5 times 8 is negative 40. Again, really important that you're good with the integers. Okay, so there's the answer to number 1. And again, if you ever want to pause and work ahead and see if you got it right, that would be fine. Let's take a look at number 18. 55 equals negative 5 times x. So negative 5 times x, we need to undo multiplying by negative 5. So we're going to divide both sides by negative 5. A negative divided by a negative would give us that positive x that we're after. And a positive divided by a negative is going to be negative, and 55 divided by 5 is 11. So there's our answer on that one. Okay, let's come back here and let's take a look at number 8. So here's number 8. And this is those problems that I was talking about where they're a little bit interesting. I mean, we kind of have the variable by itself. We've got negative p equals negative 15. But remember, we don't want to know what negative p is. We want to know what positive p is. So we don't want negative p. We want its opposite. We want positive p. And we don't want negative 15. We want its opposite. We want positive 15. So again, if you were to plug that in there, does that make it true? Negative times positive is negative equals negative 15, so that checks out. And you could just go through and divide both sides by a negative, or multiply both sides by a negative, and we end up with a positive over here and a positive over there. So we're in good shape there. All right, good luck with the assignment.